Okay, so now let's have a look at some word problems and applications. So let's have a look at example 14. There's quite a lot of reading involved, so let's use a highlighter and highlight any important information as well. So it says here, a garden supplier provides live plants for displays in 5 penthouse patios, 7 office foyers, 3 banks, and 4 hotels. The plants in each different type of display are listed below. So the patio display consists of 2 ferns. So patio needs 2 ferns, 1 camellia, 1 geranium, and 2 hanging baskets. So they're the types of plants. The office needs 1 palm, 1 geranium, 3 hanging baskets, and 2 indoor plants. The bank needs 1 palm tree, 3 camellias, and 5 indoor plants, while the hotel displays need 2 palms, 3 ferns, 2 camellias, 2 hanging baskets, and 5 indoor plants. Okay, the wholesale cost, so the cost of each plant bought by the supplier is $22 for ferns, $18 for palms, $8 for geraniums, $15 for camellias, $12 for hanging baskets, and indoor plants cost $10 on average. Okay, so the supplier needs to be able to use this information to calculate the cost of displays, the number of plants required, and profits, but in this form, the information is difficult to handle. There is a lot of information going on. So we are going to use matrices to display the following information, and then we've got to do some calculations in part B to work out the total cost, etc. Okay, so part A. What kind of information do they want us to display? So the first thing we want to display is the number of displays supplied to each venue. So let's define our matrix. So this is part 1. Let capital A be the number of displays. Let me zoom in. Number of displays supplied to each venue. Okay, so how many different venues do we have? We have, back up in the first sentence, penthouse, office, bank, and hotels. And you need 5 in the penthouse, 7 in the office, 3 in the bank, and 4 in the hotels. Okay, so matrix A will be a 1/4 matrix because we've got 4 venues. We've got the patios, we've got the office, we've got the banks, and we've got the hotels. And then we said that we needed 5 in the patios, 7 in the office, 3 in the banks, and 4 in the hotels. So A is a 1/4 matrix. Okay, let's look at part 2. So part 2 says, write down the number and variety of plants used in each display. Okay, so that's what the dot points are, right? So it says here, patios need ferns, camellia, geranium, hanging baskets. Office needs a palm, geranium, hanging basket, indoor plants. Bank needs a palm, camellia, indoor plants. And hotel needs palm, ferns, camellias, hanging baskets, and indoor plants. Okay, so we've got 4 different venues. How many different plants do we have? Well, we have ferns, we have camellias, we have geraniums, we have hanging baskets. We also have indoor plants, and we also have palms as well. So there's 6 different types of plants to write down. So let's define our variables. So let B equal number and variety of plants used in each display. Okay, so B is going to be, well, it's going to be a 4/6 matrix. 4 because we've got 4 different venues of patios, office, banks, and hotels. So you'll notice on the side that I've written these little words to explain what each number corresponds to. And then we said there were 6 different types of plants. So we have fern, we have camellia, LLIA, we have geranium, geranium, we have hanging plants, we have indoor plants, and then we have palms. Okay, so patios need 2 ferns, 1 camellia, 1 geranium, 2 hanging baskets. So in patios we have 2 ferns, 1 camellia, 1 geranium, 2 hanging baskets, no indoor plants and no palms. In an office we have 1 palm, 1 geranium, 3 hanging and 2 indoor. Okay, so we've got no ferns in the office, no camellias, 1 geranium, 3 hanging, 2 indoor and 1 palm. For the banks we've got no ferns, 3 camellias, no geranium, no hanging, 5 indoors and 1 palm. And lastly for the hotels we have 3 ferns, 2 camellias, no geraniums, 2 hanging, 5 indoors and 2 palms. So B is a 4 by 6, 4 rows by 6 columns matrix. Okay, part C. Part C is saying write down the matrix for the cost of each plant. Okay, so that's where the last sentence comes in. So ferns cost $22, palms is 18, geraniums is 8, camellias is 15, hanging baskets is 12, and indoor plants is 10. All right. So C. Let C equal cost of plants, bracket dollar symbol. Make sure you have units because cost has units. You're not buying this in number of elephants. You're buying this in dollars. So C equals, okay. So see up here how I've got the plants in the order of fern, camellia, geranium, hanging, indoor, and palms. Because matrix C is also related to the different plants, you should have the order of the plants exactly the same as B as well, so you don't get mixed up. So on the top here we've started off with fern, then we have camellia, double L, then we have geranium, then we have hanging plants, then we have indoor plants, then we have palms. If you don't have the order the same, then later on when you do matrix multiplication and operations, your answers will not make sense. So we said before that ferns cost $22, camellia is $15, geranium is $8, hanging plants is $12, indoor is $10, and palm is $8. So the cost is a 1 by 6 matrix. There you go. Okay, so we've defined our matrices A, B, and C. So we've actually written down let A equal, let B equal. On the side of our matrices, we've also written small subsections of what each column and row represents. We also have the order the same. So for example, A went patios, office, banks, and hotels. In B, we also go in order of patios, office, banks, and hotels. We don't swap the order of the different venues around because, again, later on when we do matrix multiplication, our answers will not make sense. Now let's do some matrix operations in part B. So part B says, use matrix operations to determine the following. Part 1, the quantities of each plant needed to fill the orders. So how many plants do we need for each venue, right? So really all you're trying to think about is, well, if I have 5 patios, right, and each patio needs 2 ferns, then in total I need 10 ferns, right? That makes sense. And if I have 5 patios to fill up and each patio needs 1 geranium, then I need a total of 5 geraniums to fill up all the patios. And you're just trying to add all of these together with the patios, office, banks, and hotels, right? So for example, if I'm trying to work out how many ferns do I need in total, well, okay, we know that patios need 2 ferns and hotels need 3 ferns and the office and banks don't need any ferns. Well, I have 5 patios for 2 ferns and hotels, I have 4 hotels for 3 ferns. So 5 times 2 is 10. Plus 4 times 3 is 12. So in total, I need 22 ferns. So that's the idea of trying to work out B part 1. So let's write that down. So B part 1 says I need number of plants needed. Well, number of plants needed is the same as number of venues multiplied by number of plants per venue, right? Venues by number of plants per venue. So number of venues is matrix A, number of plants per venue is matrix B. So really we're just trying to multiply these two matrices, because remember, matrix multiplications involves the addition as well, so that we can add up the 5 lots of 2 plus 4 lots of 3, because there's 5 patios and each patio needs 2 ferns, and we have 4 hotels and each hotel needs 3 ferns. Now this is where the thinking comes in. Okay, I need to multiply the two matrices A and B together. So the question is it A times B or is it B times A? Which order of matrix multiplication makes more sense? One way to check is to check the dimensions, obviously. Another way to check is just literally look at the row by column and which one doesn't make sense. So if we check the dimensions, so if we have A times B, A was a 1 by 4 and B was a 4 by 6, right? So if I do A times B, yes, the inside dimensions work, and I should get a 1 by 6 matrix at the end. And you're thinking, does this make sense? Am I expecting a 1 by 6 answer? Well, yeah, because I have 6 plants in total, and a 1 by 6 should give me 6 for the 6 plants, and 1 is the total number involved. On the other hand, if you consider B times A, B is a 4 by 6, and then A is a 1 by 4. This itself won't work because the inside numbers won't match up, right? So dimension-wise, we know we want A times B, not B times A. Expectation-wise, yeah, we are expecting a 1 by 6 answer because we're trying to find a total number of plant for each of the 6 plants. I'm expecting 6 numbers in total. And then the final check is, does the row by column even make sense in A times B, right? So if I did go A times B, well, A is 5, 7, 3, 4, not 34. Make sure you put gaps next in between your numbers. And then B is a 2, 0, 0, 3. Don't need to make it that big. Let me shrink that a little bit. 2, 0, 0, 3. 1, 0, 3. Is that it's 2? 1, 1, 0, 0. 2, 3, 0, 2. 0, 2, 5, 5, and 0, 1, 1, 2. Does it even make sense to go row by column? Well, if I go row by column with the first row and first column, what does that number give us? Well, that gives us 5 times 2 plus 7 times 0 plus 3 times 0 plus 4 times 3. That actually gives us 5 times 2 is 10. And 0 and 0 gives still 10. 4 and 3 is 12. So that gives us a total of 22. Now remember back when we were talking about, we are expecting 22 ferns in total, because if there's 5 patios and there's 2 ferns per patio, then we need 10 ferns in total for patios, and then we need 4 lots of free ferns for the hotel. So in total there's 22 ferns. So this checking of row by column, yeah, the number 22 does make sense. It's what we anticipate, it's what we expected to look at the total number of ferns. So checking that dimensions work out, yes. So we know we can multiply A by B. We are expecting a 1 by 6 answer because we're expecting 6 individual numbers for each of the different types of plants. And finally checking, does it even make sense to multiply row by column? Yes, it does, because it matches with our initial expectations of having 22 ferns in total. So having checked that our multiplication A times B makes sense, not B times A, let's actually multiply it out. So you can either multiply it out using a brain or using graphics calculator. So we get 22, 22, 12, 39, 49, and 18. So if we label a cross on the top, this represents the number of ferns. Then in the same order as how we labeled everything else, so we went fern, camellia, geranium, hanging, indoor, and palms. So again, order makes a big difference. You can't just randomly mix your orders around, otherwise your numbers will not make sense. So the third order was geranium, then it was hanging, then it was indoor, and then it was palms. So using matrix multiplication, we can work out, therefore, sentence conclusion, we need 22 ferns. Whoops. We need 22 camellias. We need 12 geraniums. We need 39 hanging plants. And we need 49 indoor plants. 49 indoor plants. And we need 18 palm trees. Okay? So when you're doing these word problems, number one, order is important. Don't just randomly mix them up. Number two, when you're matrix multiplying, always check, does dimensions work? Obviously, if dimensions don't work, then you can't even multiply them. Check, is your resulting dimension, is it what you expect your answer to be? Have a quick check of your row by column. Does row by column make sense? Does the number it produced make sense? Is that what you expected? And finish off with a sentence conclusion. So that's B part 1, which is looking at the quantity, the number of plants that each venue needs to fill up the displays. Number 2 is the supplier's total outlay to provide the display. Total outlay is another way of saying total cost. So how much does it cost for the supplier to provide for all these displays, right? So how does this tie in with our labeled matrices? Well, if you go to matrix C, it's the cost for each plant, right? So if in part B, part 1, we've worked out we need 22 ferns, right? And each fern costed $22, then the total number cost for ferns is just 22 times 22, right? That's pretty obvious. And if I needed 22 camellias and each camellia costed $15, then the total cost would be 22 times 15 worth of camellias to buy. So what that's really telling us is if we multiply AB, which is the total number of plants needed, by the matrix C, so the total number of plants multiplied by the cost of each plant, then we should get the total cost answer. And in terms of total cost, we're just expecting one number as our final answer because we're not expecting the cost for each individual plant. We just want one number which tells us the full amount total cost to buy all of these plants. So let's write it out. So part 2, we want to work out total cost, which by definition or just by common sense, total cost is the number of plants multiplied by the cost per plant. That's pretty common sense, straightforward, cost per plant. So from part 1, the number of plants is A times B, because that produced for us a 1/6 answer, because it was a 6 individual numbers of however many each plants we needed to have. And then multiplying by C, the cost of each plant. Well, what dimension is C? It's a 1/6. Okay. So reasonably, total cost is number of plants times cost per plant. So technically that's A times B from part 1 times C, which is the cost matrix of cost per plant. Now do your checking. Do your dimensions make sense? Can we even multiply A, B, and C together? Well, if I go 1/6 times a 1/6, that's not good. We can't multiply that. So that tells us that we need to adjust matrix C. So if we could adjust matrix C so that it becomes 6/1, then that's good because the 6 inside matches up, and on the outside I should get a 1/1 answer, which is what I expect because I just want one single number to get me the total cost. So we need to adjust matrix C. So let C transposed be 22, 15, 8, 12, 10, and 8. So that's the ferns, that's the camellias, that's the geraniums, that's the hanging, that's the indoor, and that's the palms. So C transposed is now a 6x1 matrix. So now we can say that total cost is A times B, that gets us the total number of plants, times C transposed. So again, do a dimensions check. 1/6 is AB, and then a 6/1. The insides match up, and on the outside I expect a 1/1 answer. So that's just a single number, a 1/1. And again, check, does it even make sense to multiply? Check your row and column. So AB, matrix AB looks like, let me find it again. Oh, sorry, it was a 1/6. So it looks like 22, 22, 12, 39, 49, 18 by a C transpose, which is a 6x1, 22, 15, 8, 12, 10, and 8. So far, dimension check, yes, it works. Expectation check, a 1/1, yes, I'm expecting a single number answer. Third check is check your row by column. Does multiplying row by column make sense? So remember, column C transpose going down, that's the cost for a fern, that's the cost for a camellia, that's the cost for a geranium, etc., etc. Whereas going across here, AB, this is the number of ferns needed, this is the number of camellias needed, number of geraniums needed, etc. So if I went row by column, that's 22 times 22, which is the 22 ferns by $22 per each fern, plus 22 camellias, lots of $15 per camellia, plus 12 lots of geraniums multiplied by $8 per geranium, adding on, etc., etc. So yes, that does make sense, because working out total cost is however many plants we need multiplied by the cost of each plant. So then using a graphics calculator or just multiplying out in your brain, that should get you 2192. So sentence conclusion, therefore it would cost $2192 in total. Part 3 of B, it says the charge for each type of display. So work out the charge for each type of display if the supplier adds, so they add on 80% profit to the cost. So what that means is, okay, part 3, oops, it's too many dots. Part 3, so we want an 80% profit. Profit means we need to increase the price, right? So rather than just charging each fern $22, each camellia $15, etc., etc., we need to increase that price by 80%. So new cost is equal to 1.8 lots of C, because that's the new total cost. So we're trying to work out the cost per display, okay? So we're not working out the total cost of every single display combined. We're just trying to work out the cost per display. So if you're going back to the matrices defined, all right, so A really is useless to us right now because we're not trying to find the total cost of all 5 patios. All we're really caring about is how much would it cost for one patio. And one patio needs 2 ferns, 1 camellia, 1 geranium, 2 hanging plants. Right, so what we need to combine is matrix B, which is the number of plants needed for each display, right? And we also need C, the original cost of the plants. So really, cost per display would then be B, which is the number of plants per display, and we need to multiply it by the new cost. Right, so B times 1.8 C. Now again, be careful of your dimensions. So B was a 4 by 6, All right, so B was a 4 by 6 matrix. 1.8 treated, it's a coefficient, so you can actually pull it out in the front and you can multiply it in later. Well, C is at the moment, C is a 1 by 6 matrix, right? And this is where we come up with the same issue as last time. Well, the inside dimensions don't match up. How do we fix that? Well, we could easily fix that by turning C into C transposed. And so we end up getting a 6 by 1. And then, well, yes, the inner dimensions match up. So technically my expected answer is a 4 by 1 answer. Well, does it make sense to have a 4 by 1 answer? Well, the question's asking us to find the charge, how much does it cost for each display? And we do have a total of 4 displays, so it does make sense to expect a 4 by 1 answer, because that means there's 4 entries and every entry has 1 number, so that would be the cost for each of the 4 venues. The next thing would then be to write down your matrices and check, does it even make sense to multiply it out row by column? So I'm going to treat 1.8 as a coefficient. I'm going to matrix multiply B and C transposed first. So B as a matrix is 2, 0, 0, 3, 1, 0, 3, 2, 1, 1, 0, 0, 2, 3, 0, 2, 0, 2, 5, 5, and 0, 1, 1, 2. C transposed was a 6 by 1, which said 22, 15, 8, 12, 10, and 8. Okay, so check, row by column doesn't make sense. If I multiply this row by this column, would that answer make sense? Well, what does this 2 represent? This 2 represents the number of ferns needed for the patio. This 22 represents the cost for each fern. So if I have 2 ferns in the patio and each fern costed 22, then multiplying it together gives me the total cost for ferns in a patio. And then row by column means I have to add on 1 times 15, which makes sense because 1 times 15 gives me the cost of camellias in a patio, plus 1 times 8, which is the total cost of geraniums in a patio, plus 2 times 12, which is the total cost of hanging plants in a patio. So yeah, it does make sense to go row by column for each of your venues. So using a graphics calculator, we end up getting 163.80, 147.60, 203.40, and 370.80. So remember, the order of the 4 in this B matrix was in the order of patio, office, bank, and hotel. So that means the order for this resulting matrix is also patio, office, bank, and hotel. And this is why the order is so important, and that you don't just mix it up however you like it, because if you mix up the order, then multiplying the numbers will not make sense. So let's finish off with a sentence conclusion. Therefore, it costs $163.8 for patios, $147.60 for office, $203.40 for bank, and it costs $370.8 for hotel. Make sure you leave your answer in 2 decimal places for cost, because in money we deal with dollars and cents. So it's reasonable to have your answer to 2 decimal places, not 1, because we don't go, oh, it's $370.8. It's 80 cents for the hotel. So make sure you check your answer is reasonable as well. And because I used a graphic calculator, I should go back and just write in saying I used a graphics calculator. So using graphics calculator, just to let the reader know I used a graphics calculator, and I used a graphics calculator up here as well. So using graphics calculator, and I used a graphics calculator back over here as well. So using graphics calculator. Yeah, so with these word problems, start off by defining your matrices and variables. So let C equal blah, 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 brackets, units, and then write out your matrix, label your side entries of your matrix, and always keep them in the same order, consistent order, so that your matrix operations do make sense later on. When your matrix operating, always 3 things to check. Number 1, does it make sense to even multiply? Do the dimensions make sense? The inside dimensions, do they match up? Number 2, do the outside dimensions match up with what I expect my answer to be? If I'm expecting a total cost, which is a single number, and my matrix multiplication gets me a 1/6, that isn't sounding very good. And the third thing to check is row by column. Does my row by column make sense when I'm multiplying